Welcome back. This is Vince again with the Tinkerer's Workshop. This video is part 3 on the Atlas Universal Compound Vise. And in parts 1 and 2, I take the vise apart and clean it up and then reassemble it. So if you haven't seen those 2 videos, you might want to take a look at those. In this video, I'm going to take the vise over to my drill press and mount it and just try it out. Before I do that though, I have a little confession to make. As I was reassembling this, I was following a drawing in an old brochure that I had from Atlas, and I think that I actually mounted this entire carriage slide backwards. So I had it flipped around 180 degrees from the way you see it now, and once I started to take it over to my drill press, I realized that it put the crank handles sort of in an awkward orientation. So I slid this off, flipped it 180 degrees, and just put it back on. So if you're watching part 2 and you see me assembling this and are thinking to yourself, hey, that looks backwards, it is. So I just wanted to clarify that in case anyone is actually rebuilding one of these themselves and is a little bit confused by that. So let's go ahead and take this over to the drill press and get it mounted and see what it can do. Well, since we're talking about the Atlas Universal Compound Vise, I thought it was only appropriate to set it up on my Atlas drill press. Obviously, you don't have to have an Atlas drill press to use this, but you do need a drill press that has a table with slotted holes in it like that so that you can mount the table in place. It just gets bolted down. So we'll go ahead and do that now. Alright, there's not much to mounting this table. You want to start just by wiping off your drill press table to make sure there aren't any chips or debris on here, and then just set the Atlas Universal Compound Vise in place. It doesn't really matter how you have it squared up here because you're just referencing off the drill bit or your single point here, so it can really be any position here. I just get it roughly centered, and then you also just want to make sure that you have enough clearance here for this crank to turn freely. If you have it too far, it won't work, so you got to make sure it's set out far enough for that. This one's not as much of an issue because it's up higher, but once you get it roughly positioned, it just attaches with some bolts, and those just drop through and then fastened underneath with another washer and a nut. And I'll just put that in loosely for now. I'll go ahead and do all 4 of these all around and then just kind of get it situated right where I want it. Like I said, it's not real critical where you get it, but you just want to make sure it's bolted down securely. The compound vise is securely bolted to the table now, and I've raised the whole drill press table up a little bit just to get it into a more comfortable working height with the drill chuck. So like I said before, I'm not going to use this for milling because drill press chuck just really isn't made to take that heavy lateral sideways thrust that you'd get from moving a workpiece underneath a milling bit. But what I do want to use this for is workpiece positioning for drilling holes. And here's an example of what I'm going to be doing first. This is a metal spinning tool rest that you use it in a wood lathe, but it's designed for metal spinning, and it's essentially just a piece of square bar stock with a row of evenly spaced holes. And I've got a piece of bar stock to make a duplicate of this, and what I thought I would do is clamp this onto the table, and that way I could position it under the drill bit, drill a hole, and then use the cross feed to advance it exactly 1.5 inches to drill the next hole, and so on down the line. And that way I'll end up with a row of precisely spaced holes that are guaranteed to be in a straight line. So in order to clamp that up, go ahead and add the vise jaws. This is the first one that's got the key milled into the base, and that just slides on here. And that key locks it into the T-slots on the table, so it ensures that the face of the jaw is parallel and perpendicular with the T-slots. So go ahead and lock that down. Now, even though this is parallel with the T-slots, what's really critical is that the face of this is in line with the X-axis feed screw. And because this table can swivel, you really have to dial this in and get it set up so it's perfectly parallel. Because if it's not, you can have your workpiece clamped between the jaws here, and if it's, this is exaggerated, but if it's way out of whack, as this travels in this direction, eventually that workpiece is going to travel so far off that it won't even be under the drill bit. At the very least, your holes will end up, even though they'll be in a straight line, they won't be parallel with the edge of the workpiece unless you get it positioned so it's parallel to start with. So I'm going to go ahead and get this set up and show you how we get this zeroed out so that it's perfectly parallel with this X-axis cross screw. All right, we're looking just underneath the table right now, and on this swivel there's a series of graduation marks for degrees, and there's a witness mark on the table itself. So you can swivel that table and we'll get it lined up to the 0 mark as best as we can here. This is just a very crude adjustment, but it gets you in the ballpark. So once that's aligned, I'll go ahead and lock the cap screws, and then we'll test it to see how close we are. Those index marks on the swivel will get you pretty close, but the only way to really know for sure that the face of this vise jaw is parallel with the X travel here, the X-axis travel, is to tram it, and I'll do that using a little dial indicator like this one. This has got a little button plunger on the back, so I'll just go ahead and chuck this up in the drill press. And then I'll bring this jaw up against the dial indicator, about like that. Zero out the dial here. And now I'm just going to run this using the X-axis crank to see how far out we are. And that actually is looking really good right out of the gate. Boy, I would say we're probably definitely well within 1,000, probably more like within half a thousandth there. So that's perfectly acceptable for what I'm going to be doing here. If it was out much further than that, I would loosen the cap screws underneath the table and then make a minor adjustment to the angle of the table, tighten it down, and just run it back and forth against this dial indicator again until I got it to where I want it. But like I said, this is plenty good for what I'm doing, so I'm going to go ahead and clamp up the workpiece and get started drilling some holes. I've got the hole locations laid out on my bar stock just to serve as a reference. And then I've also got a center drill mounted in the drill press chucked up there. Because this workpiece is longer than the travel distance of the table, I'm going to have to start at one end, and I've backed this table all the way to the right, and I'll start at one end of the workpiece and drill probably 3 or maybe 4 of the holes, and then I'm going to have to, once I reach the end of the travel of the table, I'll have to bring it all the way back, unclamp the workpiece, and reposition it to drill the remainder of the holes, but we'll cover that as we get into it. Right now I'm going to clamp this up between the jaws, so we'll go ahead and add the second jaw here. And just to make it a little easier to see what we're doing, I'm going to raise this workpiece up by placing it on a couple of spacer blocks here. So we'll bring that jaw in place, tighten it up with this cap screw here. And then this jaw here is actually what applies the clamping pressure, so you tighten these 2 screws and just snug those up to hold the workpiece in place. That seems good. Okay, now that I've got the workpiece clamped, I can use the cranks here to maneuver the workpiece underneath my drill bit to get it exactly where I want it. And I'm just going to eyeball this because the actual location is not super critical, but I'll start just by bringing the drill bit down and then using the crank to move this where I want for the y-axis location. And then I'll do the same thing with the x-axis. That looks good. And now before I start drilling, I will zero out the dial on the x-axis cross-feed screw just so that I have a reference to start with. But I'm going to go ahead and do that off camera, and then we should be ready to start drilling some holes. I just wanted to zoom in here for a little closer look. This is the crank handle for the x-axis, and you can see that I've zeroed out this micrometer dial here so the zero mark lines up with our little witness mark on the collar. Each crank of this handle, each revolution of the handle advances the table 1/100,000ths of an inch. So in order to get the 1.5 inch spacing that we need, I'm going to have to turn this crank handle 15 times in between each hole. So I'll drill a hole, turn it around 15 times, stopping at the zero mark here, and drill the next hole. And it's just a matter of repeating that process in between each hole. Okay, that crossfeed dial is zeroed out. I'm in position to drill the first hole, so I'll go ahead and get a little cutting fluid on there. And turn on the drill press. Okay, now I should just turn the crank 15 times. "11, 12, 13, 14, and 15. And that takes me right to the second hole. So go ahead and drill that one. Alright, that's as far as the travel on the x-axis will let me go, so I'm going to have to back this all the way out. And I'm going to back it out here, and then I'll advance it back to 0 on the dial here. Okay, so I've got this back returned to 0. It fits right there at that first hole. And I'm going to go ahead and unclamp this. And I'm just going to go ahead and align this so that just use the drill bit as a registration mark and get it so it's positioned the workpiece right under the drill bit where that last hole was, and tighten up those clamps. right. Now I can just go ahead and drill the last 3 holes. All right, got the last hole drilled. Let's take a look. So they did a pretty nice job. I've made these tool rests before, just setting the workpiece on the table and trying to eyeball it, and I can never get a nice clean straight row of holes, so just sighting down at that did a really nice job. So I can see using this little XY table for a lot of positioning jobs like this. Like I said, I won't use it for milling, but for drilling holes in metal workpieces, I think it'll come in real handy. So I hope you like this series of videos, and if you feel like it, go ahead and hit the subscribe button. I appreciate all the comments and all the support. Thanks.